So we've done, in terms of chemical formula, we've done where you have one metal and one non-metal, right? So we've looked at how, for example, sodium chloride is NaCl because sodium is group 1 and chlorine is group 7, right? We've looked at the ones where you have molecular ions. So, for example, sodium sulfate. Right, the sulfate ion has a 2- charge and sodium is +1, so that ends up being Na2SO4. So you have 2 sodiums for every sulfate. And we talked about how you must keep the formula of the sulfate ion. You must keep those 4 oxygens attached to the sulfur. So that's the formula of the sulfate ion. So today we're going to look at the last thing, when you don't have a group 1, 2, or 3 metal, and you have a transition metal. So if you have a transition metal, for example, here's something you'll see, copper 2 carbonate. Okay, so copper 2 carbonate might appear in the acids topic because it will react with acids to form salt, water, and carbon dioxide, right? And it's a green solid. I think that was in the periodic table topic that you need to know it's a green solid. Okay, and if you look on your data leaflet, actually at the bit where it's about solubility, you'll find it's an insoluble, right? It's an insoluble solid. It does not dissolve in water. Anyway, what is the formula of copper 2 carbonate? So the first thing to realize is that if you have a transition metal, right, you cannot use the periodic table to decide its valency, the number of electrons it will lose. So I'm going to scoot up here to our periodic table. So if you look at the periodic table on the transition metals, so they go from, right, so all the way over here. Oops. So all of these, right, all this box here, there's no way, they have no group number. And that means that you can't tell exactly how many electrons they lose. They will all lose electrons because they're metals, and they can lose different numbers of electrons. So you need to know how many they've lost. And what you do is you go to the back of the data leaflet. So if we go here, so what you have is you'll be given this number, this 2, and then you go to the data leaflet and you find what it is. And you can see here that it means that the copper ion has a 2+ charge. So if we go to our method again, we're going to put, so we're going to do exactly what we did before, right? Lose charge, drop and swap, but it's 2+. That's what we need to find out. And then carbonate. Remember, carbonate is CO3 is the chemical formula. Okay, so just to remind you, remember that the chemical formula is any of the small numbers, and the charge is 2-. And then we will lose the charge. If the numbers are the same, they cancel down. And then when we drop and swap, we actually just end up with CuCO3. Okay, so let's have a look at, what about iron 3 sulfate? What kind of chemical formula will that have? So this time, you have iron 3. So if you think you can do it, have a go yourself before you play the rest of the video. So iron 3, first thing we need to look at is iron 3. Okay, that means, so the 3, the Roman numeral 3 means that it has a 3+ charge. That is consistent with them all. Okay, so iron 3 sulfate, we know it has Fe, so the chemical symbol of iron, and we know it has sulfate, which is SO4, and then putting in our charges, got a 3+ here, we've got a 2- here, and we are going to lose the charge. We're going to drop the number. Oops, I didn't. And swap it over. Okay, and because we have 3 sulfates, we're going to need to bracket that to show the whole lot is 3. So that comes out as Fe2 bracket SO4 bracket 3. Okay, so I'm going to put a few here and see how you get on with doing them, and then I will go over the answers after. So what about lead 2 hydroxide, silver nitrate, what about zinc chloride? So remember, when it ends in IDE, you're back to the data leaflet, so the periodic table. How about chromium 3 sulfide. Okay, so have a go with those. Pause the video and I'll be going through them. I'll be working through them when you get back, or you can fast forward to get the answer. So lead 2. So again, let's have a look. So it's Pb for lead. And hydroxide is OH. Charges, or lead is 2 plus, and hydroxide is minus. That's bad enough. Okay, and then we lose the charge, drop and swap. Only one hydroxide, sorry, 2 hydroxides, 1 lead. We'll need brackets. And it ends up as Pb bracket OH bracket 2. That's lead 2 hydroxide. Let's do silver nitrate. Silver is just a single positive charge, so it's Ag and NO3 for nitrate, plus single minus. So when you lose the charge, there's nothing to drop and swap, and that ends up at AgNO3. Okay. Zinc chloride, so Zn, it's Zn2 plus Cl. Right, chloride is group 7, so it's minus Zn2 plus Cl minus. Lose the charge, drop and swap. Get one number, so we get ZnCl2. Chromium 3 sulfide, so out here, deliberate, it's not sulfate, so it's on the periodic table again. It's chromium 3, so chromium is Cr, sulfur is S, sulfate with oxygen, 3 plus, sulfur is group 6, so that's a 2 minus. So if you lose the charge, drop and swap the numbers. You end up with Cr2S3. So chromium sulfide is Cr2S3. And last little bit I want to do with this is, what about if you have covalent substances? Now, I think the easiest thing is just to learn them, all right? Although I will mention, so water, right, I will say that hydrogen has a plus and oxygen is 2 minus. Now, they're not ionic. This is the problem. So, like, you could do your drop and swap and you'll get H2O, but you probably know that. And CO2, you could take carbon as plus 4. Ammonia, you definitely need to learn that. There's nothing about its name that's going to help you, although nitrogen is minus 3 if you think about it, and hydrogen is plus 1. You would expect them to combine in that ratio. Hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. And just to give you a hint, if you go, just this might help somebody on the day. If you can't remember the formula of sulfuric and nitric acid, basically you can add as many hydrogen ions as it takes to neutralize it, or sorry, not neutralize, to cancel out the charges. So because nitrate is a single negative charge, it'll only have 1 hydrogen, so it'll be HNO3. And because sulfate has a double negative charge, it ends up with 2 hydrogens. So it would be H2SO4. So just as, what else? If you had methanoate and you wanted to make the acid of it, it would just need 1 hydrogen ion. Hydrogen carbonate would have 1 hydrogen ion. I don't know, that might not help, but you never know. That's how I remember it. And or you just learn the formulas. Okay, so we'll leave it there for formulas.